Start. Yes, recording has started. Okay, you can
Sir, am I
start.
audible?
Yes, you are
Sir,
audible and
sir,
your
screen is visible,
line
sir?
also visible. Yes, it is
Okay.
visible. Okay,
Okay.
please start.
Okay. Good evening, everyone. Myself, Riju Nandi. So, I am doing PhD in NIT Rourkela. So, I will present the defined MPPT technique and experimental result and experimental setup also in PV emulator. So you can see that my layout of presentation is MPPT technique. So defined MPPT technique I will describe means P&O method and INC method and PSO method. Also experimental result also P&O method varying irradiance, suppose increasing, decreasing, and so also some increasing, decreasing like that. Okay, so I also track MPP maximum power tracking in PV emulator. uh, I will show it also for the INC method, same as PSO method. Next slide is this is the so this is the P&O MPPT, is perturb and observe MPPT. So this is the flow chart. You can observe that the start sense VS and IS, voltage and current, the sense, and calculate the power. So power means VS into IS. Then calculate dV means voltage, deviation means dV. So VS minus VS minus 1, like same as dP is a deviation of power. And like that, also if dP greater than 0, if yes, then dV greater than 0. Also no for dV greater than 0. But when dV greater than 0, yes is VR equals to Vs minus 1 minus dV. Also for no, Vt equals to Vs minus 1 minus dV. So like that, you can see that a flow chart. Okay, the equation are dP by dV greater than 0 and dP by dV less than 0. This is the left hand side for the right hand side, and for the MPP point dP by dV equals to 0. Then is INC MPPT. You know the INC incremental conductance MPPT. So this is the flow chart. You can see that you can the flow chart that start same like a P&O, VS and IS from PV system. Then the delay is there. Then VS minus 1 and IS minus 1. And dV is same like P&O, that deviation of voltage and deviation current. But there is a no power deviation. This is also dV depends on there is a only deviation current and voltage. So you can see that dV equals to 0 when yes, that di equals to 0, and for no, di by dV equals to minus I by V. This is the INC formula. The di by dV equals to minus I by V. So also when di by dV equals to yes, that time written no di by dV greater than I minus V. So if then yes, increase VR means voltage increase, some increase from deviation dV, and for no, voltage decreasing, same like di. So when di greater than 0 means decrease VR means voltage is decreasing minus dV. So also if it is yes, then increase VR. So here the equation is at the point in the left hand side of the MPP means maximum power point. So that time del I by del V greater than minus I by V. At the point of right hand side MPP, del I by del V less than minus I by V. And at the point of maximum power point, del I by del V goes to minus I by V. So next is a PSO method. So uh, PSO method. So there is a flow chart is there. This is a flow chart. So start, then input system parameter is there, that you have to limit that value. Then initiate particle speed and position. Then decide objective function, calculate total power of the two module. So like that, evaluate the fitness value of each particle. Then search P based and G based. Update the speed and the position of the particle based on. So recalculate the total power of array in PV array, and reevaluate the fitness value of each particle, determine whether update P based and G based according to that position. So if it is that after decide objective function, if it is no, that check whether condition is satisfied or not. If it yes, then output optimal solution, then end. So this is the particle sum automation, that is this self-organized system inspired by natural and biological behavior. Particle sum optimization is an optimization method that iteratively improves a candidate solution by utilizing particle position and velocity in search space. So this is the means minimum describe I have done all the position, because I will do that experimental setup. So this laboratory session. So this is my experimental setup. You can see this is my experimental setup. So there is a PV panel is there. So PV panel is a lux meter also, is measure the how much irradiance is coming. An ammeter is there. This a portable solar power supply is there. Also boost converter is there. This is a I have used the converter for boost converter for the maximum power tracking. Then there is a 12012 transformer is there for the driver circuit, for driver supply circuit, and for also sensor circuit. This is the load. This is the DSO. This is the variac. Variac means changing the irradiance. Suppose 500 to 700, 700 to 1000, like that. You can see that upper view. This is the upper view, and this is I have done the I have made that boost converter in PCB with PCB designing. Okay, so there is a boost converter I have designed. So there is a also inductor I have designed all the part. So you can see that a voltage and current sensor is there. I am using voltage current sensor for the calibration. That output after voltage and current sensor calibration, that voltage and current going to Arduino at Mega. So there is a for the voltage current sensor plus minus 15 voltage supply is there. This is a current probe for the current measurement, and the driver circuit also there to drive the switch. Also Arduino Mega that I have told about this. So I have got that result. Okay. So that piano technique. So piano technique, you can see that is a fast result is a variant irradiance, means 500 to 700, then 200, then 700, then 400, like that. This is a power, this is a voltage, this is a current, same as you can see that output voltage, current, and power. And this is the decrease in the irradiance for 600 to 400, 300 to 0, and this is the increasing part. You can see that you increase 0 to 300, 300 to 600, the 500 is a 1000. And that you can see that that I have shown that I got this from PV emulator, that I have that time I have shown that this I have done the maximum power tracking in the PV emulator. You can see that I have this MPP tracking, MPP point. This is the left hand side and right hand side, and this is the MPP point. So now I'll show the hardware implementation and P&O technique. So you can see. So you can. You can see acha, is it visible that simulation? Hello.
Yeah, it's visible.
Oh, you can see that this is the for the Arduino setup. Okay, for the implementing the hardware setup, that MATLAB code I have done. Code not code, MATLAB simulation I have done. Yeah, you have seen that A0 and A1 is there. Arduino means Arduino is the input, analog input is there. This A0 and A1. So for A0, I assume, not assume, but for hardware, I will give VPP, means voltage, and A1 for the current, means voltage and current. Then go for that. This is a P&O technique. P&O, you can see that is a P&O coding is there. There is a P&O coding is there. Okay, there is a P and MPPT coding is there. Okay, so you can see that coding is there. So this after that we got the I got the output in pin number 3. Pin number 3, 20 kilohertz. Pin number 3, 20 kilohertz frequency. Pin number 3. Okay, because pin number 3 supports 20 kilohertz, 15 to 20 kilohertz, I think. But that's why I choose pin number 3. So so you can see. Uh, Acha. Is it visible the Arduino at Mega? Okay. So I have dumped this code to Arduino. So go to the hardware position. Go to the hardware. So there is a hardware setting is there. You click the hardware setting. So already I have selected Arduino Mega 2560. You can see that if you are using Arduino Micro, Arduino Nano, Arduino Uno, Arduino Uno, so you can choose. So I am using Arduino Mega 2560. That's why I choose Arduino 2560. Okay, so that okay. Then you have to do monitor tuning. You can see that after monitor the tuning, that is blink. That will blink that Arduino. You can see. It takes some time, means 1 minute. So you have seen that that Arduino blinking because coding has now monitor tuning. After monitor tuning, I will dump that code, means or the simulating portion into the Arduino for the generating PWM. So okay, taking it coming. Okay, so then I'll stop there. Then build and deploy. You can see that option is there, build and deploy. That up, then build and deploy. After build and deploy, you can see there is some blink is coming. Blink, you can say, so already deployed. Okay, now I'm going to show the hardware setup and how to track the maximum power tracking. Then I will show. Okay, wait for 2 minutes, and so wait for 2 minutes. Okay, for hardware setup. Video is visible?
Yes.
So you can see that
Yes, slide is visible only.
okay. You can see this is the boost converter.
Only slide is visible, Riju.
No, sir. Video is coming. Video is.
Acha, from your end.
Participant, please confirm video is visible or not. Visible,
Yes,
sir.
visible, sir, visible. Just click on the video, then that page will be zoomed.
You can see that this is the boost converter. I have designed the PCB designing. Then this is the inductor, and this is the voltage and current sensor circuit. And this is the potential circuit. This is the Arduino at Mega. I have done already that. I have already done that P&O method. This is the for switch protection circuit. Okay, this is the for resistance, and this is the PV emulator. This is the PV emulator. This is the for laptop for the tracking purpose. Okay, so this is the DSO to supply the Arduino at Mega, and yeah, and for the duty pulse and current and voltage. So how I the driver circuit and supply circuit. This is the 30 voltage I will give it. 30 voltage and ampere current rating is 1 ampere. ISC 30, VOC is 30, ISC is 1. So you can see. You can see check the EMP, then we should check 1 ampere. You cannot resist it. But 30 volts is coming. So
Riju, can you please remove that slideshow mode?
okay, okay. Okay.
That is your video, Riju.
So you can see that is 0, 1, 2, 3, 1, 2, 3, Arduino, 1, 2, 1, 2, 3 position, and the ground for the output, and the input is that after the potential circuit, it will go the A0 and A1. I already discussed that for A0 is voltage. For A0 is voltage and A1 is current. Okay. Now I will give the 30 voltage. You can see. basically depends on resistance. Because when the source is equals to that time taking the maximum power. So we have to change the resistance value for taking the point. So you can see that it already tracked the maximum power point for the boost converter P and O method. Already tracked the MPP point. You can see that MPP level. Okay. So now I'm going to show that changing ingredients, how to track the maximum power trip. Okay. So this part is already done, already covered. So this part is already covered. So take some time. So just wait for 2 minutes, 1 minute, then I describe all the things. Okay. So now we can see that PP panel is there. So varying the ingredients, I will show that how to change the maximum power trick, how to it will track the maximum power tracking. Okay. So this is the variant is there. So I will change the variant to track the maximum power tracking. This is the DSO. So
Sir, I think I'm not getting sound. So I do not know about others, but
Acha, you're not getting sound. So am I audible? Hello.
You are audible,
Hello.
properly
Hello.
audible. You are
Achha.
properly audible.
Okay, sir.
Please carry on.
Take times for 5 seconds. Okay. This math product is here. This is the code. So I have to change some resistance of the maximum trip. So it is the like for the PV panel, this PV panel, VOC is some around 7.5 volt. So it is VOC. Okay. So VAC for VMP it will come like near about 7 volt. The current is a little bit because the current is so much and it means 0.1 ampere. But for the PV panel, PV emulator, it will go up to 8 ampere, 10 ampere. Okay. It can show that it's going 6 volt. Okay. And 6.2910. So this is the 6.5. So you can see that near about 7 voltage will come. Okay. You can see that DSO. You can see there now. I'm going to show the DSO value. Just observe this the DSO value. The irradiance. So I'll vary irradiance from this. Okay, then you can see that how to change the irradiance or to take the maximum per strip. So it takes some time because for the second now is 5 seconds for the changing. You can show. You can see that when I'm changing irradiance, that it will take the maximum power and change the irradiance. Then I'm going for some values 0. It's 302 like now is 50 watt per meter square. I'll give. Okay. Can see that value. Can see that value that power also. Power also that is the power. The last position. This is the power. This is the current. The 3 is the current and 2 is the voltage. And voltage is at like say 7 to 7.5 volt. And current is little bit 0.1 ampere and power is same like that. Okay. So this is the for P&O method. So now time is 7:40. So I'll give also that for INC as same and I also PSO method is already there. So I'll show in the desktop that that PSO coding and also INC. So then if you have the time, I will show the experimental setup. No, because my colleague also, his PhD colleague also there, he will present another thing part. Okay. So wait for 2 minutes for I'll show that show the PPT for the also simulation, some simulation INC and PSO technique. Screen is visible. Hello. Hello.
Yes, your skin is visible.
Okay. So that already done that MPP technique. Okay. You saw that in the PV emulator I have tracked the maximum power point like that. Okay. And for the hardware result, it will for the hardware result it will track that, say, for the increasing. I have shown only decreasing part. Also for the increasing, for the changing, like the increasing, decreasing. Okay. For the like INC same, and for the PSO result also. Okay. So you can see that for the INC technique, same, that A0 is there. Same A0 for the VPB, and A1 is IPB, and this is for INC. In incremental conduction, coding is there, and you can see that the coding part. Coding part means coding part. This is a function part. You have to code it. Okay. Then you will get the pin number 3 output. Okay. Same like for the PSO technique. The same. So you have to change only this part. This is the function part. You have to change only. If you will go this part, you can see this is the PSO technique. This is the programming part is there. You can see that programming part is there. If you want, you can see that all the programming part I have done this, that a PSO technique. So same like we have done all the part in the hardware experimental setup, like a P&O technique. You have shown already that how I have done the technique in P&O technique in hardware portion for the PV motor, as well as for the PV panel. Okay. So that's it for my side. And then my colleague will present, Mainak Biswas will present another part, means how to sense like temperature sensor for the reading sensor for the Arduino. Okay. So any question about it, and then I will move forward. So any question from this side, that for the result? This is the experimental setup. So there is a small resistance I have used, but for today I have used that changing resistance part, the big resistance part. So any question about it, that P&O technique, how to deploy that hardware part? Hello. Okay. So we'll go further, because my colleague will present some PPT. Okay. Stop sharing. Okay. Some question will be there. Okay. After my friend will present, you will tell me the question. Okay. For 5 to 10 minutes.
My screen is visible.
Is
Can you
visible.
please confirm?
Is visible.
Okay, thank you. Hello. So, okay, now it's visible properly.
அவங்க பிளேஸ்மெண்ட் ஆஃபீஸர்கிட்ட பேசிட்டாங்க.
Sorry.
இப்போ என்ன இது வருது, என்ன கண்டிஷன் வருது?
Yes, properly visible, full screen mode.
Okay, so I'm discussing about the part like data logging from the temperature sensor and from the EDN sensor. So for that, I am using LM35D, which is the temperature sensor. That is showing the analog value only. And for that EDNs, we are using the ambient light sensor. That is basically PMT 6000. That is for the ambient light sensor for EDNs. So moving forward, so that what is the objective for that? So the first objective is to read real-time data from the temperature sensor and the ambient light sensor. That is for the EDNs. So next, to interface both sensor with Arduino and transmit the readings via serial port. Okay, so and next objective is that to record all the sensor value in a CSV file using Python. Then we'll demonstrate the basic data acquisition from without SD card, and for future use we can use the SD card also or IoT modules. So for that, the component required is for that project. First one is the Arduino Mega. You can use Arduino Uno, Arduino Nano. You can use any kind of Arduino boards. Then LM35, that is basically a temperature sensor. Next, the ambient light sensor, that is for the EDNs. And for USB cable to connect the PC connections, jumper wires, breadboard, Python IDE. That is basically for the Python code, and PySerial and CSV Python libraries to store the CSV files. So that is a physical circuit connection. The circuit is very simple. So we can use the VCC and ground for the VCC is 5 volt, or you can use the 3.3 volt also, and LM35 and same connection for the ambient light sensor. So and signal or data, we are using A0 as same like MATLAB. Previously Riju has shown A0 and A1. Then we are using Arduino for connection for COM port. That is basically COM3 from my PC, and you can use COM3, COM4, any kind of COM ports. And power and the ground, both are the for both sensor, that is same. So that is the Arduino code review overview. I will after that I will just show the Arduino code also. So just demonstrate. First, we read the analog values from the pins like A0 and A1, and that will convert LM35 reading to the Celsius That is the temperature value to Celsius, and it will send the data in CSV format via the serial port. For my case, that is the COM3, and the time is in ms, that is millisecond, and the light value and the temperature, that is Celsius. Okay, and the sampling interval is 1 second. In every 1 second, that value should be changed. Okay, so after that, the data printed in serial monitor or captured via Python. First, we will see the data in the serial monitor in Arduino IDE. Then that data will capture by using Python, and will store in the CSV format also. And then the Python script overview. There's a very simple script in Python. Like Python script uses the PySerial to read the serial data from Arduino, and it will in each line from Arduino is save that data like in CSV format, whatever the sensor will give to us, that will save like sensor underscore data.csv format. Then the CSV file contains in time, light sensor value, same like previous, and the temperature in Celsius. Okay, and we can plot or analyze later in Excel or Python tools. That is the future thing. So that is the sample output. I will show the output in Arduino IDE also. That is a sample output, like first the time in millisecond, then the light value, then the temperature. First 1000, 2000, 2000, 3000, that is the time basically in millisecond. Then 512, 520, 498, that is the light value. That is the light value data from capturing from the sensor only. Then that temperature like 26.4, 26.5, 26.6, like that. That is basically the temperature sensor. And each line corresponds 1 second of the log data. So that is the advantages as for and the future scope for that. Like that is very simple and low cost data logging setup, and it works without SD card. If you're using SD card, that is also fine, but for my case, I'm using the PC storage only to save the CSV file. You can use the SD card also, and it will work without internet connection. And so for the remote areas, like and data is easily analyzed using CSV tools. Okay, so the future scope is that I already told the SD card for offline storage, and you can include the RTC module basically for real timestamps. So for that, we'll conclude that the LM35D and ambient sensor like TEMT 6000 sensor logging system provides a simple platform for real-time environments like data collection using Arduino and Python. That setup can be explained for research like IoT applications or academic or demonstrations. Okay, so that is the sliding part basically. After that, I'm sure. So screen is visible or not? Okay. So this is the Arduino code basically. So this is only a 23 lines code, nothing else. Only that is a pin definition, like define the pins like A0, A1, and this is the setup, and that is the loop part. It's a very simple thing. Okay, and we are print those things like temperature, light, what is the light and light value, like sensor value, and the delay is basically 1000. Well, like 1 second delay basically. 1000 means 1 second delay, and we are using Thorny for the Python scripts. Like same, whatever the setup we are done. So we are just check the sensor value from the serial motor also. Then we are just capturing the data in Python and save it to the CSV format for the future use. Okay, so that is basically the data. And if you see the setup, just a minute, I'm turning on my camera. Setup is visible. That's a very simple setup. Camera is visible. Hello.
Visual. Code is visible, but
No camera is visible.
Camera is not visible.
1 minute. Camera is visible. Oh, okay, you are joined for 2 years now. Wait for a moment. Now visible.
Now visible.
Okay.
So that is the very simple setup. That is the, we already told that ambient light sensor, that is the sensor, ambient light sensor, TMT 6000, and the temperature sensor, LM35D. So we are connecting using Arduino board, that is Arduino Mega, and that is the simple connection using breadboard, the ground VCC and the analog ports. And if you just whatever the thing, if you just turn on the flash for the ambient light sensor, and it will reflect in our screen also. I'm showing, actually screen is not visible. Visible? See the 9898983, that is the basically light or the irradiance value. If you remove the light, the value is decreasing basically. And after that, that is the temperature, 87, 88. That value we should like calibrate like 20% or 30%, but for now we are just using for 86.02 like that. So basically thing is that if you are using the light, then the sensor gives the value like 642, 956 like that. If you remove the light, the value is decreasing. The same, this is Python code for basically to capture the real-time data from the sensor, and the same thing we are capturing in our Arduino serial monitor also. See, already we are capturing from the Python, so that's why here is not connecting the COM ports, so that is showing basically. If I turn off it or stop it, and then see, the value is coming here, but the value is coming here, Arduino. The same value we are capturing via Python and we are saving it into our file like sensor data.csv, like where it is saving basically. See, in my case, see, sensor_data.csv, that is a CSV file. If you robotics, that is a CSV file, and so the data is saving. For now, I don't have the CSV viewer, that's why it is showing that Excel. So that is the part. So that sensor value we are directly not storing in our storage, and it will replicate in our system. That is our future goal. So any questions? That's it from my side. Hello, am I audible?
Yes, you are audible. Any questions from the participant end?
From the both setup, for my side
Yes.
or for both, you can
Any
ask question
queries
now.
if you have, so please let us know.
Hello. Am I
Yes,
audible?
ma'am. Yes,
Sir,
ma'am.
I'm Reshma from MIT Manipal. I have a question for the previous one. Like you had shown an experimental setup, right? So it was for two cases. One for uniform shading, another one was for a partial shading condition. So initially you have used a PV emulator, right?
Yes, yes.
Okay. For the second case, for partial shading, you have not used PV emulator. Instead, you have used an actual PV panel.
Not a PV panel, yes.
Because in emulator, we don't have that options for partial shading condition, right?
Yes, yes, yes. For that
Mm.
emulator part, this partial setting is not available like that. For this PV emulator, this is value will be changed. I have to change my value also. That PV emulator, PV panel is different. PV emulator is some different.
But PV emulator only for uniform shading it is possible. For non-uniform irradiances, it is not possible.
Yes, yes.
Okay.
That is not possible. This is for I have shown for the MPP point how to track the maximum power point.
That was for uniform.
Mhm.
Yeah, at particular value of
Yes.
irradiance.
Yeah, yes, yes, yes.
Okay.
That I have changed all the value also. What is the VOC value? What are the ISC value? Okay. That it is depend on irradiance also, because you have to change also irradiance. There is a part is there 1800, 900 also there. You can change
Okay.
also that part in emulator.
So have you published paper on this? Like I mean, for my references, any papers are available?
No, just I have not published yet, but I will be published. And that I'll try within 6 months, 1 year. I'll publish that paper.
Okay.
Different MPV techniques.
Okay. Sir, can I get your like email ID or something like through coordinators or someone else?
Yes, yes. Dr. Arnab Ghosh sir is there, my my supervisor. He will contact. We will contact him.
If possible, let him share it in the group,
Okay,
WhatsApp
okay,
group, if
okay.
possible.
Sir will share it. Okay, okay. Sir will share it.
Yeah. Thank you. Thank you.
Okay. Any question or?
So I think no more questions. We can wrap up. Sir, you will there?
Yes, thank you. So thank you for session. So today this laboratory session was is our last session. So tomorrow morning sharp 9 a.m. Then we'll join. Okay.